Okay, group, this is Dr. Rowley, and this is General Chemistry 2. This is our online version of the class. This is the first day. We'll see how this goes. I've never done a fully online course before, so this will be one big experiment, well, in a number of ways. So today, I'm going to start with a narrated PowerPoint. I'm not always going to do a narrated PowerPoint. I'm hoping to do more real videos, and I'll talk a little bit about that as we go along with regard to what I'm hoping to see, what the expectations are. What I'd like you to do is go to Moodle and open up your Moodle page and open up the syllabus. So if you go to the syllabus, and by the way, I'm doing this on my other computer at this point. Let's see, so I'm going to Moodle, and I'm going to open up right above everything is syllabus. So I'm opening up the syllabus, and I'm looking at it, and so we're going to follow along with that throughout the course of this PowerPoint presentation. All right, now, as we move on to the next slide, I want to mention Alex. Alex is really the thing to keep in mind right now, that if you haven't done the math review and any of the pre-tests, go in and do it. This is the course code, this REWGU-HVENL, and make sure that you register for this specific section, because this is my section, the online class of General Chemistry 2 that I'm teaching. Alex includes the e-text version of the book, and it also includes the homework stuff itself. If you've had Gen Chem 1 at Bethel last fall, and if you used Alex for that course, then you should still have an active license agreement with them, and there should be no change to your status. If you already have your copy of the textbook and you don't need it, you can choose the opt-out button. You received an email from the campus store about that. The opt-out you should do within the first 2 weeks, and they will not charge the cost of Alex with the packaged ebook to your account. You will need Alex for the course. So if you choose to not do the ebook, then you'll need to at least purchase or at least have access to Alex. Again, if you have it from first semester, it's valid for this semester. If you're new to Bethel, or if you had Gen Chem 1 a while ago, then you will have to get the updated version of Alex. Alex with the ebook packaged is the default. If you've already got your version of the book, then you can opt out of Alex and ebook and just purchase Alex by itself. So the most important things are that you finish the math review by tomorrow night, which is Tuesday, and then we're going to start with chapter 13 for Alex. And part A is, it opens up at just after midnight Tuesday, so early Wednesday morning, and that is due Friday night, and then part B of chapter 13 is due next Tuesday. Most of the chapters in General Chemistry 2, I've broken into 2 parts, not all. I think one chapter is just 1 assignment, and then another chapter is 3 Alex assignments. But I try to break it up so that there are 1 to 2 Alex assignments due per week. So it spreads out the when the objectives need to be met. Okay, so if you haven't already signed in to Alex and taken the math stuff, do it before tomorrow night. That's when it's due. So please do that. I would ask if there's any questions, but that doesn't seem quite relevant right now. So I'm just going to keep going. And let's see. So other announcements. So there is no lab this week. No lab this week, no lab this week, no lab this week. So if you have lab on Tuesday, make sure that you don't come to lab on Tuesday. I emailed my lab sections. I announced it in my other class, so I'm announcing it here. Please make sure that you don't come to lab this week. So along with that, instead of lab, I'm really expecting to communicate with each of you in the class one-on-one. So I've already scheduled most of you with 10-minute sessions. Thank you for all 20 of you who have already signed up. And there are 6 more that I would like to also get on the schedule. This will help me to put a name with a face and a voice, and these are all Zoom meetings. So I've already created a Zoom link for those of you who have signed up before, let's say, 5 o'clock tonight or 6 o'clock tonight. Oh my goodness, it's after 6:30 now on Monday evening. By the way, I do apologize for not getting all this stuff done earlier. It has been one crazy day, including about an hour at the dentist this afternoon. So I'm way behind on getting all this stuff posted. So I hope that in the future I will get all of this stuff posted much earlier in the day on Monday, Wednesday, and Friday. Okay, so when you come to lab next week, make sure that you have a lab manual. Now, the lab manual they have in the campus store. We produce that ourselves. I don't know, it's in the neighborhood of $20 or $22. Make sure you have that. You will also, and that you have to have this year's lab manual. You will also need a lab notebook. The lab notebook is spiral bound. It is a duplicate page notebook. There are 100 pages in it. You need to have a lab notebook with these duplicate pages in it. Now, you can get them at the campus store. I have no idea how much they run there. If you know of someone who has had General Chemistry 2 before, or organic, or biochemistry, or an upper division chemistry class, you don't have to have a completely brand new lab notebook. In other words, you can start writing in a notebook not on page 1. So you can use someone else's if you can find someone, if it's available, or if they're around. You can certainly get a new one, and then if you go ahead and purchase that, I would encourage you, especially if you're taking organic, go ahead and buy a brand new lab notebook, because you're going to get plenty of use out of it. I know students who have gone through 4 or 5 lab notebooks during their time at Bethel. All right, so that's enough about the lab notebooks. Make sure you also bring your goggles to lab next week. And remember, there's 2 types of goggles. They're the ones that will just get you by. They're the lower cost ones. If you're going to go and take another chemistry course, if you take organic, you're going to want the more comfortable goggles. I know they cost more, but boy, it makes a difference if you're wearing them for hours at a time. All right, I've already talked about Digital Direct. And then lab next week, what we're going to be doing is we're going to talk about how to use the lab notebook. We'll walk through the first lab, and we'll walk through how to do the experiment. My goal is next week, especially if you have my labs. I don't know about the other lab instructors. My hope is that when you come into lab, that you will be able, that we will walk through all of the policies and procedures. We'll go through the experiment. You will do the experiment, write it up, and turn it in before you leave. That's the goal for next week. All right, and I think that would be a worthy goal for you to have. All right, how are you doing so far? Are you hanging in there? All right, that is lovely. Okay, so this is a little bit about me. So as far as introductions go, what we see here, this is my family. Here I'm in the upper left picture. My wife and I were in Arizona last week, and they ended up having snow on some of the mountains, and it was really very beautiful. But that's my wife. We have been married for 40 years of this past Christmas, and we have 3 daughters. They are in the upper middle. On the left is Amy. She's our oldest. In the middle is Allison. She's our youngest. And on the right is Andrea. She's our middle daughter. So 3 girls. And the baby down below, Amy, who's on the left in the picture of the 3 girls, she has 2 children. The left, or just below their picture, is Lainey. She's 2 months old. And Amy's other child is Bodie. He's in the orange shirt. He is 3. And then I have two grandchildren with my daughter on the right, Andrea, my middle daughter. And you see those them in the pictures on the right. So Micah and Summer are in the lower right. And Summer she's my girl. Summer has always been my girl. That's her with me there. One last thing, I have three granddogs, and they are actually in order of my daughters in the picture, and that was not intentional. That was very accidental. Amy's dog is Millie. She's there in the lower left. All three of these are female, and they are all my babies as well. Millie on the left, Avi in the middle. Avi is Allison's dog. You'll notice that Avi only has 3 legs. She had cancer in one of her legs, and just last week was her 6-year anniversary for her amputation. Obviously, she's a pretty happy girl. And then Luna, who's a mix, that is Andrea's dog. She's had Luna about 6 months. Okay, that's probably more than you want to know about my family, but hey, nevertheless, that's who we are. All right. Now you know that I want to talk with you because I want to see who you are and get to know a little bit about you, a little know about what your goals in life are, where you're headed, and so forth. So that's why I really want to have these 10-minute conversations with you. I'm hoping that we'll be able to connect in different ways during the course of the semester in some face-to-face manner. All right, so I spent a lot of time on the introduction. Here is the agenda for today. We're going to talk about the syllabus. I know that you've patiently had this up on your computer for, about 8.5 minutes now. And let's see, I want to talk a little bit about the Moodle site. We'll talk about the iron sheet and the iron quiz coming up. After we go through these other preliminaries, after the syllabus and stuff, I'm going to give a brief review of General Chemistry 1, and I will talk about Chapter 13, just a little bit. We're going to move into Chapter 13 today. All right, I would normally ask any questions, but hey, you can always pause it. You can call me, email, whatever it takes. We'll move on with that. Okay, so before we do this, okay, I'm going to stop right here. Before we go through general chemistry and review, I want to talk about the syllabus. So you've got the syllabus open, and if you want to print it, you're certainly welcome to. There's one change that I need to make to the syllabus. But let's take a quick look at it. I'm not going to read it all back to you because I'm assuming that you're capable of understanding what's there. Let's see. As far as ALEKS, I've talked enough about ALEKS, and most of you are familiar with ALEKS. So it's going to be graded that 90% of your grade for ALEKS is going to be progress on objectives. So for example, these Chapter 13 assignments that are due, the first one Friday and then the second one next Tuesday, those progress on objectives, excuse me, that's 90% of your grade for ALEKS. The other 10%, which will be at the very end, is overall PI completion. If you complete 95% of all of the objectives by the end of the semester, you will get full credit, which will be 10% of your ALEKS grade at the end. So when we're taking percentages of percentages, I realize that can be a little confusing, but I'll try to explain that more as we go along. There will be quizzes. Quizzes will be on the average of once a week. They will be online, of course. They will be timed, and you will have to take them within a certain time frame window. You may only use a calculator for the quizzes. You may not use any kind of internet resources. You can only use something to write with. I would urge you to have pencil and paper and a calculator for each quiz. The quizzes, you will have between 5 and 6 minutes to take a quiz. So it is timed. It is limited. The quizzes are going to be over material that we have just covered. So I'm going to be giving a quiz on Friday. I'll tell you later exactly what that's about. But usually if a quiz, let's say if a quiz is on a Wednesday, it will very likely cover material that we covered in class on Monday, and perhaps something related to a worksheet problem that we're going to be doing. Which leads us to worksheets. Okay, by the way, at the end of the semester, I'll drop 1 to 2, usually 2, sometimes even 3. If we take 15 quizzes, I'll drop the lowest 3 quiz grades and average the rest. Worksheets. Worksheets are, I'm going to have, not every day, but probably a couple of days a week, I'm going to have a worksheet assignment that you are going to be assigned to a group of 3, and you will need to work together and submit it jointly as a group of 3, and that will be graded. So some worksheets will be you will work through together. Some worksheets you will do individually. All worksheets will be uploaded to Moodle. All worksheets uploaded to Moodle. Now the worksheets are graded not particularly for accuracy. They're really a completion thing. Have you gone through it? Have you worked it out? Have you put in the effort to do it? So worksheets are basically points that you get by doing them. Make sure that you upload them as a PDF by the due date. Worksheets are the simplest way to get points in this class. Basically, if you show up, participate, and pretend to be interested, then you can at least get 9% of your points on worksheets. There's 4 exams, and there is one change to the syllabus that I'll mention. The 4 exams, by the way, these dates are correct except for one. The 4 unit exams, and again, these will all be on Moodle. You will have an hour and 10 minutes to take the exams. They will be timed, and I'm going to be scheduling them. Now, my plan is to schedule them, and I'm going to want to hear back from you. These are going to be synchronous. These are going to be synchronous, and they need to be synchronous on Friday, February 19. So these are all on Fridays. And I'm going to need to give some thought to this because I may need to adjust these dates a little bit. My goal is to have the exams done by the weekend, and I want these to be at a time where people can all make it. Here's what I think we'll do is if you can't take it at the time I schedule, you can come in and take it at the testing center. So we'll work this out, but I'd like everyone to take the exam at the same time. I want to be able to see you, and I want everyone to be taking it together. So, that's the challenge for doing an online class. So, actually, what I may be doing is scheduling these for something like a Thursday, maybe the day before the Thursday at 4 o'clock. I'll tell you what, I'm going to send something out soon about what we'll do for timing of this. As you can tell, I'm thinking out loud. I have this extremely carefully planned out, of course, as every step of the way here. The one thing, I know I'm going to be out of town on Friday, March 12. So I'm planning right now for having that exam probably on Tuesday the 9th or Wednesday the 10th. The problem is I'm leaving town on Wednesday afternoon and would not be able to monitor that, but we'll see. Right now I'm going to plan on Wednesday, March the 10th for exam number 2. So that's one change to the syllabus. Exams 3 and 4, they will be around those dates. So these dates are not etched in stone. They are going to be either Thursday or Friday, except for March the 12th. That's probably going to be Wednesday, March the 10th. The final exam we will take synchronously. That is on May 19th. That is study day, 8:30 a.m. I'm just arbitrarily putting it there because that is when no other exams are scheduled. So I know it could be a hassle trying to get things synchronous, but we've got to have some times when we are all synchronous. The lab component, well, everyone takes lab face-to-face. Lab is not a remote option. So you must be registered unless you've already taken it and received credit for it. You will need to be in lab face-to-face. There are 6 lab times, 3 on Tuesday and 3 on Thursday. I'm teaching 2 labs on Tuesday. So if you are in one of those labs, I'll look forward to working with you and meeting you and chatting with you during those times. There are 4 other lab instructors, and you're going to love whoever you have. They're all good. So let's see. Make sure that you're ready for lab when the time comes. As we scroll down to the last page of the syllabus, grading. So quizzes are 10% of your overall grade. Worksheets, again, just doing the worksheets and submitting them, that's 9%. ALEKS is the single biggest component. Make sure that you stay up to date with ALEKS. You may not like it. It may not like you. Work through it. By the way, the science help sessions start this coming Sunday. Sunday at 7:45, I believe. And so the science help sessions, hey, take advantage of those Zoom opportunities. I will also be available mostly during my office hours, which are Monday, Wednesday, Friday from 11 to 12. We can set up Zoom meetings during those times as well. And if we need to, we can work on setting up maybe some group study times during the week. And I may look into doing that as well. But I want to get as much Zoom time or direct visual contact with you as possible. The 4 unit exams, each unit exam is 11%, and then the final exam is worth 12. The final exam is cumulative. I'll talk about that a lot more when the time comes. So you know the textbook, this Burge and Overby, 4th edition. We are covering the second half of the book. Not all of it, but most of it, as you can see in the schedule on the last page of the syllabus. Okay, this might be a good time to take a break. Maybe pause the video, pause this PowerPoint, and step away. I'm going to pause it and get a drink of water, and then move on to the next slide. Okay, here we go. Let's see. For General Chemistry 1 review. General Chemistry 1 may seem like a distant memory. It could have been a long, long time ago. If it was, go back and spend some time reviewing. We are going to come back and review a number of these concepts from Gen Chem 1. Things you really have to know. There are certain, Gen Chem 2 is not all about memorization. Gen Chem 1 is not all about memorization. Now, there are certain things that you have to know and certain things that you've got to be able to do. But the primary focus of Gen Chem is learning processes and procedures. It's not just about memorizing large tables of data and facts. But some of the things you do need to know, you need to know naming. So if you go to our lovely Moodle site again, you will see that there is an ion list, and this is right under the syllabus. By the way, don't worry about announcements. There are none. When I say announcements, I mean announcements on the Moodle page. So the syllabus and the ion list, those 2 documents you should download and take a look at. The ion list, you have to have these memorized by Friday, because there will be a quiz on Friday that will be about naming. Naming ions from the list. You need to have the exact correct formula, and you need to have the exact spelled name. So, for knowing your ions, yes, it's very important that you memorize this by Friday. Review it by Friday. Naming is the language that we use for chemistry, and if you can't use the language, then it's just not going to be a great semester for you. So this is why I pound so hard on this memorizing the names. You've got to understand your ion names. Okay, so the early concepts, chapter 1, significant figures. You need to know sig figs. Now, in general chemistry, we typically use 3 significant figures for answers or for problems. Not always, sometimes we use 2, sometimes we use 4. If an answer should have 3 significant figures, and you give it to me with 2 or with 4, that will usually still be acceptable without a penalty, usually. Unless the question, of course, is specifically about significant figures. Let me give you an example. So let's say an answer to a problem is 5.00. Well, if you just write 5, then you will lose a point because that's one significant figure when you should have given 3. Okay, so here are a few things from chapter 1, other things you need to know. So aside from the importance of knowing the names and formulas of your cations and anions from the ion list, you need to know your metric prefixes. You've got to know, for example, without any help, that 1 meter contains 1 times 10 to the 9th nanometers. You need to know that nano is 1 times 10 to the minus 9th meter. The temperature scales, you should know how to use equations. You don't need to memorize equations. If I need to convert a temperature, I will look up the equation for it because I don't remember a lot of equations. What I will try to do is, I'm expecting you to know how to use them given enough information. All right, for these people, yeah, they did some things. You should know the basics. For example, you should know that Bohr and Schrodinger worked on the atomic structure. Bohr, remember, had the idea that electrons travel in circles around the nucleus. Schrodinger said, well, kind of, because the Bohr model only worked for hydrogen, or more specifically, the Bohr model only worked for 1 electron systems. Schrodinger came along and said, you know, the electron is so tiny and it's traveling so fast that it probably has wave properties. So Schrodinger came up with the wave equation, which means that electrons travel around the nucleus as standing waves. The reason we use those theories is because they work. It's not because they're absolute truth, it's because they work. So here are just a few names. I would know one thing about each of them. All right, formulas, isotopes. You should know what isotopes are. Same atomic number, different atomic mass. Same number of same number of protons in the nucleus, different numbers of neutrons in the nucleus. So we've got carbon 12, 6 protons, 6 neutrons. We have carbon 13, 6 protons, 7 neutrons. And we have carbon 14, 6 protons, 8 neutrons. The number of protons determines what element it is. The number of protons is the atomic number. If you change that, you change the element. The number of neutrons only affects the mass. You know what atomic and molar mass is. How to convert moles to grams, grams to moles. Percent composition and empirical formulas, those are opposite functions. From a formula, you get percent composition. From percent composition, you can calculate an empirical formula. So you need to know naming of ionic compounds, molecular compounds, of acids, which are like ionic compounds, but hydrogen is the only cation, and the first 10 organic compounds. We will talk about this more as we go through Gen Chem 2. All right, atomic theory, atomic structure, quantum numbers, electron configurations, Hund's rule, Pauli exclusion principle. Go back and review these if you don't already remember them. If you've got exams from Gen Chem 1, go back and review them. Any materials that you have, go back in the text and review these ideas. Periodic trends, such as atomic size. Electronegativity is a really important one. How strongly does an element want to draw electrons to itself when it's bonded in a molecule or in an ion? Ionization energy is important. There's one that's missing, and that is electron affinity. The only time I'll really mention electron affinity is right now, and you don't really have to know anything more than that because I won't speak of it anymore. All right. So when we get to bonding and molecular structure, this is one of the core concepts of Gen Chem 1. You've really got to understand molecular structure because it is how these atoms come together, the number of bonds they like to form. You had a whole lab in Gen Chem 1 where you built Lewis structures and named geometries and identified molecular shapes and determined whether they were polar or not. And you looked at bond angles. All of these things come together, and this is fundamental to why molecules behave the way they do. How big is it? How polar is it? Does it like to dissolve in water or not? We ended with molecular orbital theory and hybridization. Just a couple of more. The sophistication. Molecular orbital theory is very sophisticated and very challenging to understand, but it's the most complete and the best theory that we have. For most of what we want to do in general chemistry, simple models like Lewis structures do us very, very well. Stoichiometry. In stoichiometry, it's where you have a balanced reaction. Stoichiometry is only dealing with moles. It's the mole ratios of things. So if you have reactants A and B, so let's say you have 1A plus 2B, then you've got a 1:2 molar ratio. That is stoichiometry. Stoichiometric ratios are the coefficients you use in a balanced equation. So keep in mind that all that stoichiometry is the molar proportions, the whole number proportions of one component to another from their balanced equations. Now, going from moles to grams or grams to moles, that's using molar mass. Going from, so anyway, you can, all of these other pieces that are part of under stoichiometry here on the slide, they are types of calculations that we've used. Now, in this slide right here, excuse me, I'm going to need more water here in a minute. The moles to moles in the center, that's the stoichiometric proportions. How do we get to moles? We can start with grams and use molar mass. We can start with molarity times volume, solution chemistry. That will lead us to moles. We can use the gas laws, PV equals nRT, and we can find moles N from gas phase species. Once we have converted to moles of what we're trying to find, then you convert to grams or solution molarity times volume or PV over RT. How you get to moles doesn't matter. That's characteristic of the material. But the moles to moles piece, that's stoichiometry. All right, different types of reactions. We talked about these three fundamental types of reactions: acid-base, precipitation, and redox. We are going to spend whole chapters in Gen Chem 2 talking about each of these. With acids and bases, probably more like a chapter and a half to 2 chapters. Precipitation, maybe half a chapter. And then oxidation reduction, well, that deserves its own chapter as well. So these are the three reaction types we will keep coming back to. And this is why Gen Chem 2 is linked to Gen Chem 1, because we keep using those principles over and over and over again. And we're building on what we've learned before. All right, so also in Gen Chem 1, we talked about gases. You know about PV equals nRT, the ideal gas law, the properties of an ideal gas, and these other things that are related to gases. You won't need to memorize equations or constants, but you should recognize what an equation will do for you, and you should know how to use it. The next to the last chapter that we cover in Gen Chem 1, or anyway, near the end, is heat, enthalpy, delta H. Thermodynamics. We start with thermodynamics. We do a lab in Gen Chem 1 on calorimetry. Mix two solutions, measure how much the solution heats up, and we can calculate the enthalpy of reaction. So what is heat? Let me come back to the idea. What is heat? How would you define it? Let's just think about that for a minute. If you had to put a definition of heat into words, so right now I'm asking you to think about how would you define heat if you had to give it a definition right now and write it out on a piece of paper? It's not easy, is it? How do you define heat? All right. Yeah, sorry about that. I got distracted by a phone call. So where was I? Boy, I can't do that in a real class, can I? Probably should have even said that, or maybe I can edit it out. Well, whatever. So the idea of what is heat? What is heat? Well, you know, it's the kind of thing that you know it when you see it or feel it. You can feel a blast of heat. You can touch a hot stove, not recommending it, but you know what heat is. And putting definitions around it is a challenging thing. So we're going to talk not just about heat, but also about disorder in Gen Chem 2 as well. And we're going to be combining it. So we're going to be revisiting all this stuff about enthalpy, and we'll see that again when we add the layer of disorder on top of that. We ended Gen Chem 1 talking about liquids and solids. One of the really key aspects of working with gases, liquids, and solids is relating the properties of molecules to their structure. And a lot of it comes back to how big are they and how polar are they. So this idea of intermolecular forces, London dispersion, that casual interaction, very weak for the most part. Dipole-dipole interactions, when you've got polar molecules, that head-to-tail interaction, dipole-dipole interactions are typically stronger than London dispersion. Hydrogen bonding, and then ion dipole forces. So the stronger the intermolecular forces, that makes a difference with things like viscosity. Now, viscosity is resistance to flow. The difference between water and, for example, honey. Water has a much lower viscosity than honey does. The intermolecular forces for honey are stronger than they are for just pure water. Boiling and freezing point, we're going to be talking about some of these coming up in chapter 13 as we move into solutions. So anyway, just wanted to point out, do the quick review for Gen Chem 1. If you've got a level of recognition, that's one thing. It's another thing. I would urge you to go back, review some materials from Gen Chem 1. I wouldn't study them relentlessly, but go back and do some serious review. Go back and look at some problems that you calculated from Gen Chem 1 for different types of processes. Maybe review some of your old labs, or review some homework assignments, or review some quizzes or worksheets or old exams. Whatever you have available, I would urge you to go back and do some review. You can use these slides as a basis for completing that. Okay. So we are starting Gen Chem 2 in chapter 13. We're talking about solutions. Solutions. Now, what are solutions? Solutions separated into three components. Separated into three components. Yes, we talk about solutions as a single type of thing. But the solution, think of it as the solute, which is what was dissolved. The solvent, what does the dissolving, our most common solvent is going to be water. Together, they make the solution. Salt plus water gives you the solution. Sugar plus water gives you the solution. Solute plus solvent gives you the solution. So I want to end with this slide right here, because I've been talking long enough, and if you're still awake, then that's quite an accomplishment. So let's talk about this slide. This is a crystal of sodium chloride. Sodium chloride. If you've ever looked closely at sodium chloride under a microscope or with a magnifying glass, it is perfectly cubic crystals. Perfectly cubic, just like a dice that you would roll as part of a game. At the corner, let's say at the corner of this particular crystal, we have a gray positively charged sodium ion. Well, what happens immediately when you drop it into water is that water molecules come up and they surround the crystal. So if we think, let's do this little thought experiment. Water comes up and it is orienting its negative end of the water molecule, the oxygen end, the electronegative end. The oxygen orients itself toward the positively charged sodium ion. Two or three or four water molecules approach that ion, sodium cation on the corner, and the interaction between water and those sodium cations grows stronger to the point where it overcomes the lattice energy, the energy that's holding that plus minus attraction that is holding the sodium to the chloride to its right, to its left, and the one below it. The interaction, the ion dipole interactions, become stronger than the ion-ion interactions, the electrostatic attraction between cation and anion. And water eventually will fully surround that cation of sodium and carry it off into solution. On the average, there are 6 water molecules for each sodium ion and 6 water molecules for each chloride anion. This is a process where the water has to move. Water will come up to the crystal. It will hydrate or solvate a particular ion, either a cation or an anion, depending upon which one it is. The water will orient itself to carry out the solvation process, and then it carries that ion off into the rest of the solution. That is how we get solutions. That is what dissolving looks like. Eventually, the crystal completely dissolves, and it is a fully homogeneous, clean, uniform solution. Okay, we're going to stop here, and on Wednesday, we are going to pick up with the next phase. There will be a worksheet that will be part of it, and I will have that posted to Moodle. But for now, we're going to pause, and I hope you can take some time. Make sure, if you haven't already, finish up the ALEX pretest, and then also make sure that that you've also listened to as much as you can and done some review of Gen Chem 1. All right, we'll sign out from here.